Okay, so today we're going to start section 3, and we're going to learn how to show that a quadrilateral is a parallelogram. So what we're going to do today is we're going to take all of the theorems that we learned yesterday, and we're going to flip it to the converse. So let's go ahead and see what they are. So again, the number isn't important to us. You don't need to memorize that it's theorem 8.7. You need to memorize what it says. So yesterday we saw that it started out with, if a quadrilateral is a parallelogram, then both pairs of opposite sides of a quadrilateral are congruent. Now they flipped it and they told us that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So notice they have the congruency marks on both pairs of opposite sides. So this is the first way to prove that a quadrilateral is a parallelogram. We're going to go through 5. The second way, again, we don't need to memorize that it's theorem 8.8. We need to memorize what it says. So this one says, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we would have to show that angle B is congruent to angle D, and show that angle A is congruent to angle C. If we can do that, then we know that our quadrilateral is a parallelogram. So that's the second way to show that a quadrilateral is a parallelogram. And now the third way. If one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. Notice on the sides here, side BC has both the congruency mark and the parallel mark, and the same thing with AD. Now, if my parallelogram or my quadrilateral had something that looked like this, let's say the parallel indicators were here, but the congruency marks were here, this would not be enough information. The parallel and the congruency mark have to be on the same sides. Now it's theorem 8.10, and this one states that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So you would need to probably have some kind of given information, whether it's congruency marks, or maybe they would say that BE, and I'm going to add a letter E here, BE is congruent to ED, and the other diagonals, AE is congruent to EC. If you're given this, then you could say that ABCD is a parallelogram. Now, if you want to show, instead of writing the word then, you could put the arrow, any kind of shorthand you want to come up with. So next slide. Again, these are the same 5 ways that we talked about individually. So there's 5 ways to prove a quadrilateral is a parallelogram. So again, show both pairs of opposite sides are parallel. This is actually the definition of a parallelogram. The last 4, these were the theorems. So we would show both pairs of opposite sides are congruent. That would be number 2. Number 3, show one pair of sides are parallel and congruent. Number 4, show both pairs of opposite angles congruent. And number 5, show the diagonals bisect each other. So these would be the 5 ways that you could put into your proof to show that something is a parallelogram, the 4-sided quadrilateral. The next slide, again, it's just the same 5 things again, just written in shorthand. Okay? The next slide, this has, again, those same 5 reasons. They just shortened it up. So again, we're showing both sides of opposite sides are parallel, show both pairs of opposite sides congruent, show both pairs of opposite angles congruent, or show one pair of opposite sides are congruent and parallel, or show that the diagonals bisect each other. Again, just a summary of everything we talked about. So this would be one way you could write out your reason if you're listing it in a proof. Now on the next slide, we're going to apply all of this. So here, they want us to either restate the theorem, or if it's the definition of a parallelogram, you could just put that. So for the first one, I'm going to add congruency marks here. It's kind of hard to make a congruency symbol with PowerPoint. That's what these notes are made out of. So let me add in the little wave on top. So for number one, notice it's BE congruent to ED and CE congruent to EA. Notice I've just labeled my diagonals as being congruent. They were bisected. So that's what I'm going to state as my reason. So we could state that if diagonals bisect each other, then parallelogram. Or you could put an arrow and then point to a parallelogram. Then the quadrilateral is a parallelogram. But you could just put then or put the arrow and then parallelogram. Number two, they're talking about angle BAD, which is here, stating that it's congruent to DCB, and also ADC congruent to CBA. And this reason would be if both pairs of opposite angles are congruent, then it's a parallelogram. They're telling me that BC is parallel to AD and AB is parallel to DC. This is definition of a parallelogram. Next one, number 4. They're telling me that BC is congruent to AD. BC is congruent to AD. And AB, 1, 2, 3, 4, is congruent to DC, 1, 2, 3, 4. So this reason would be if both pairs of opposite sides are congruent, then we have a parallelogram. And then the last one that says that if the same pair, so for number 5, if the same pair of opposite sides are both parallel and congruent, then we have a parallelogram. So let's add a proof here. So I'm going to give you, given AB parallel to DC and AB congruent to DC, I want you to prove that AD is congruent to BC. Let me draw a picture here. So A, B, C, D. Let me go ahead and fill in my given. So I was given that AB is parallel to DC and that it was also congruent. So let's start our 2 columns here. Statements, reasons, So number 1 will be all my given, AB parallel to DC and AB congruent to DC. And this was given. Now this will be the type of proof you're going to be doing on the quiz. So now, what does this given tell me? What does it tell me about ABCD? Beautiful. That's going to be my second step. I'm going to say that ABCD is a parallelogram. And my reason is if the same pair of opposite sides are both parallel and congruent, then it's a parallelogram. And now my third step is what I'm trying to prove, that AD is congruent to BC. And I know that if it's a parallelogram, then opposite sides are congruent. So your proofs are going to be easy if you know your properties. So if you know those theorems and their converses. So the proof on the quiz will be easy. It'll be something similar to this, where you're going to show that it's a parallelogram and then again show one of the properties. So you have homework on 8.3. You're going to do it tonight and then you're going to turn it into Canvas, and the answers are going to be posted on Canvas after 8 a.m.